All right, hi, this is Jacob Nash, and let's get back into what we were talking about here for solving a system of linear equations. So I had listed these 4 steps, and because my chicken parmesan was going to burn, I had that in the video. But now we're all good. So rearrange, what does that mean? So I'll just draw an example because that's going to make more sense. So here are the 3 equations. Ooh, sorry. Okay, so if we're asked to solve this system of linear equations, it would mean find out what x, y, and z equal. And the first step is to rearrange because it's going to be a lot easier to do this if we make the equations in the same order, like the variables in the same order, and all the constants on the side. So let's do that. So we'll have, for the first one, x, subtract y and z to the other side. And then subtract 2 to the other side. Or sorry, never mind. It already is on the other side, sorry. So the 2 remains. And then for this one, we're going to put a 0y here because we want to make sure that we have a letter for all of them. This is going to make it a little bit easier. Then the 2z remains, and then the 7 remains. And then this one, we're going to add a 0z and add the 4 to the other side. So now all of the equations look the same. Oh, so that's the first step. So we rearranged it and then we put in some filler ones just so that they'll all line up. That makes it a lot more easy to do. Now, operation, step 2, that just means you're going to do an operation to, you're going to start basically with the leftmost variable. So that's going to be x. So we're going to do something that's going to cancel out all the x's except for 1, obviously. You still need 1, but so the x's, you see them here, they're just x, x, x. So if we took this first equation and subtract it from these other 2, that would make these 2 x's cancel out. So that's what the purpose is. So like I said, you start with the leftmost variable, it happens to be x, and then you could do the same thing, like you could use this one and subtract from these 2, but it doesn't matter really which one you do. But I'm just going to do this one, equation 1, and subtract it from each of these. So like I said, I'm just going to write EQ1 so that I don't have to write the whole thing entirely. Now we're going to go right here and see what that ends up being. So obviously the top equation still stays the same because we didn't do anything to that. This one though, so since we have subtraction here, you have to be very careful that you do this minus this and don't switch it up because then you'll get the wrong answer. So x minus x is going to be 0x. Like I said, whenever you have something cancel out, for now we're just going to leave it as 0x. Now you have 0y minus y. Or minus negative y, so you got to be careful there. Minus negative y is going to be positive y, so be careful about that with the double negatives. You got to be careful. So then you have 2z minus negative z, so it's going to be plus 3z, and then 7 minus 2, 5. Okay. So then over here, same thing. It's going to be 0x. Then it's going to end up being 0y for negative y minus negative y. So then it's going to end up being z and then 2. So now step 3 is repeat. So you're going to keep repeating this process. And how will you know you're done is that all 3 equations will have only one variable in it. Right now, the only equation that has one variable in it is this, because these are 0, 0. So we already know z is 2. So we already got the answer to one of them just by that. But now, still got 2 more. Now, an important thing is that you can never repeat using the same equation. So like never go backtrack and like use this equation. Like we could not use this equation for this step that we're about to do. Again, you can never use the same one again or one from a previous step again. So now we found that we did the thing that canceled out all x's but 1. Now we need to do something that will cancel out all y's but 1. Well, this one's already canceled out, so whatever happens, we don't even need to do anything for that. And since we already used equation 1, there's no way that we're going to use it again, so we must use equation 2. And so, as it turns out, if you add equation 2 to that one, that's going to make that y cancel out. And like I said, you don't have to do anything for this because that y is already 0. And then you don't do anything for that because that is the equation that we're using. So that's all we're doing right now. So now the next step. So it's going to be x plus 0x is still going to be x. That's going to now be 0y. And then minus z plus 3z is 2z. 2 plus 5 is 7. And then the other 2 equations are going to just be the exact same because we didn't do anything to them. And once again, we're going to repeat the steps again. I'm going to just erase that to have more room. I'm definitely running a little low on space now. So now we can see that we still actually only know this one. Because the other ones, we still have an x and a z, and then a y and a z. But at least we have, the goal is you go side by side to where 2 of them are 0, 0 the variable, and then one of them is just normal. So you see 0x, 0x, x, 0y, 0y, y. That was the goal. Now we move on to the z's. It's time for the z's. This one's going to be a little bit different because of these coefficients. So that's not going to be that much harder. All that happens is we will add or subtract by 2 or 3 times an equation. So now we're going to use equation 3. We've already used equation 1 and 2, so we're going to want to use equation 3. So we're not going to do anything for that one. Once again, because we already found that z is 2, and also since we're about to use equation 3, you don't use the equation on itself. So what do you do to the top one? What would make the 2z go away? Well, this z, if you made that a negative 2z, that would work for that. So if you do 2 times equation 3, that's going to be minus 2z. So 2z minus 2z, it would make it 0z, which is what we want. Now for this one, it's just going to be 3 times equation 3 is going to make that 0z. So that's our goal. We want to make these 0z's. So now how that's going to be, this is still going to be the same down here because we didn't do anything. Oh. And then the top two equations, how do they change? So pay attention to this one because it's going to be a little bit different. So if we have x minus 2 times 0x, well, that's still going to be x. It's not going to do anything. That's minus 0. Then we have the 0y minus 2 times that is still going to be 0y. Now 2 times z minus that is going to be 0z, of course, because that's what we were trying to do. Now this one, be a little bit careful with. It's going to be 7 minus 2 times 2. That's 3. Now, once again, this is really, anytime it's a 0, it's really just going to still be that. And then y times 3 times 0y is going to be 0y again. Sorry, y. And then 3z, the point of doing that was so that we get the 0z. And then 5 minus 3 times 2 is going to be negative 1. And so now we can see that all three of these equations tell us the answers, because anything that's a 0, now you can X out. And we see that x equals 3, y equals negative 1, and z equals 2. And this is our answer. You can express that as a point, or you can express it the way that I will do it as a vector. And that is your answer to this system of equations, or solution. And so the fourth step was scale if needed. In a different video, we'll see what that means, but kind of this was a little bit what we were doing by scaling, but really sometimes that will mean that you'll have to like divide at the end, and you'll see that in a different example. But that's why it says if needed, because you didn't need to do it this time. But that's the way that you do this. So it took kind of long just because I was explaining it, but you could probably do that quicker. Just the main thing you have to be careful of is, even though these are relatively simple operations, just be careful with your signs, your like negative and positive if you're adding or subtracting. And if you have something like this, don't forget that you have to multiply that to get your right answer. So that was going to be the way we do it. Now the last thing in this video that I'll talk about real quick is how would you know if something has no solution? And then in the next video, we'll talk about how we would know if it has infinite many solutions. But how would you know if it has no solution? That was, what we just did was one solution. But this time, how would you know if it has no solution? So let's look at an example where that would be the case. So here is our system of equations this time. And what's going to happen here is rearrange. Actually, we don't need to, okay? So instead, now we do an operation. We want to do something that would make one of the x's 0x. So what would that be? It's if you did, what? I don't know how that, if you did, you added 2 times equation 1 to this one. Sometimes there can be multiple ways to do it, by the way, but this is what I'm doing. And so if you can see if you did negative 2x plus 2x, that's going to give you what it is. So now we'll do that, and what we would get is you didn't do anything to the top equation, so it's the same. The bottom equation, that makes it 0x. It's going to be negative 6y plus 2 times 3y, that's going to be 0y. And then 3 plus 2 times 5, that's 13. Now, this right here is 0, because both of those are 0. And that's what we get now. We get something that says 0 equals 13, which is not true. And whenever you have something like that, that's how you know that there is no solution. So that's the last thing I wanted to say in this video. And we'll talk about more situations in the next video and some more complex systems of equations, but that should be a good basis of how to do this. So thank you for watching.